Hello and welcome to this video about acids and bases. We're going to look at the difference between acids and bases, physical and chemical properties of acids and bases, and some different examples. So we're going to start with a really basic definition. The Arrhenius definition was named after a scientist who came up with this idea. Acids produce hydrogen ions in aqueous solutions. Aqueous solutions just mean when they're dissolved in water. Aqueous means dissolved in water. Bases are going to produce hydroxide ions when they are dissolved in water. Hydrogen ions are always hydrogen with a plus charge. Hydroxide ions are oxygen and hydrogen bonded together. It will have a -1 charge. And here are some examples. If we take this acid, hydrochloric acid, and we dissolve it in water, it's going to produce hydrogen ions as well as chloride ions. If we take sodium hydroxide, it's a base. We know that. Why? Because it produces hydroxide ions when we dissolve it in water, as well as sodium ions. This is obviously a very limited definition because it only allows for one kind of base, those that produce hydroxide ions. Another way you might hear acids and bases defined will be that an acid is a proton donor, whereas a base is a proton acceptor. It allows for other types of bases besides bases that have an OH in them. The important thing to remember overall is that when acids and bases ionize or dissociate in water and produce these ions, the acid will be producing hydrogen ions and base will be producing hydroxide ions. Some physical properties of acids and bases. You should know this. Acids would taste sour, like these lemons here. Acids also conduct electricity. Bases conduct electricity as well because of those ions they're producing when they're dissolved in water. They feel slippery and they would taste bitter. Chemical properties of acids and bases. Acids react with bases to neutralize their properties. Acids donate hydrogen ions in solution. A base would also react with acids to neutralize its properties, and it will reduce the hydrogen ions in solution. Remember, a hydrogen ion has a positive charge, and it's written like that. So where do we find some of these acids and bases? A lot of foods have acids, like lemons. They contain citric acid. Some different citric fruits have citric acid in them. Also, lactic acid is found in yogurt and buttermilk. It's also produced in your muscles when you exercise and your muscles are deprived of oxygen. Also, vinegar. It contains acetic acid. Your stomach uses hydrochloric acid to digest your food. That's right there. There are some acids that are used in industry. Sulfuric acid right here, phosphoric acid right here, nitric acid, which is not listed on, here it is, nitric acid and hydrochloric acid. Those are all used in wastewater and water treatment. Sulfuric, phosphoric, and nitric are also used in producing fertilizers. Sulfuric acid is also used to process pulp and make paper. Phosphoric acid is used in odor control. Nitric acid also is involved in making nylon, and hydrochloric acid is part of the production of asphalt. As far as bases go, you're probably most familiar with these being used in different cleaning products. Sodium hydroxide, though, is also used not just in soap and oven cleaner and drain cleaners, but also in textiles and paper manufacturing. Ammonia is used for cleaners and fertilizers, also to make rayon and nylon. Magnesium hydroxide is not listed here, but it's used as an antacid. People sometimes take it as a laxative as well. Calcium hydroxide is used in leather making, mortar and plaster, lessening soil acidity. So there are other uses as well for bases besides just cleaning products. Looking for some advanced ideas. Amino acids make up the building blocks of proteins. Write the structure of the amino acid glycine and identify the areas of that molecule that cause it to have acidic properties. Can you identify a different area that allows it to have base properties? Or look at sulfate compounds. They used to be called vitriols because the compounds look glassy. The old name for sulfuric acid was actually oil of vitriol. And you're probably familiar with the words vitriol and vitriolic. They've taken on broader meanings. What is the meaning of vitriol? And explain how it's connected to sulfuric acid. Or what is a Lewis acid and a Lewis base? Those are different ways of defining acids and bases. Maybe you have other ideas. I look forward to seeing what you come up with, and we'll see you in class.